All right, this is going to be a recap, which is a great way to study for the quiz, and then some interval notation. So first of all, if we have an f of x function here, we can evaluate a couple of things. Here, they would like us to put 2x into the input spot. The f function says 3, input squared, so my 2x is going to get squared. F then says plus 5 times input, and it's not just 5x because my input is 2x. And then we'll go ahead and calculate. PEMDAS says exponents first. 2x times 2x is 4x squared times by the 3, 12x squared plus 10x. All right, let's take a look at what you need to know if you have to plug in a negative x into the x spot. You're plugging in a negative. The f function says 3 times your input squared. Negative x has to get squared. Plus 5 times input. My input is a negative x. A negative times a negative makes positive. X times x is x squared. So the answer is 3x squared minus 5x. F of x plus 2. Let's go ahead and put a quantity into f. I have to put my input there and square it, and then there and multiply it by 5. Okay, 3. My input has to get squared plus 5 times input. I'm going to FOIL this out first. Don't forget your equal signs. FOILing out that quantity is x squared, outers and inners, plus 4x plus 4. I'll distribute the 5x plus 10. Final answer in descending order is going to be 3x squared plus 12x plus 5 is 17x plus 12 plus 10 is 22. And finally, letter D. This is one that we did in class quite a bit. It has a 3 in front of the function. So what we're going to do is put a 3, and then your f of x function is going to go next to it. This is 3 times the function. The function is 3x squared plus 5x. So this answer is 9x squared plus 15x. So a variety of function work that you can do. The next thing that we did was the difference quotient, and the difference quotient formula is a huge fraction bar with what in the bottom, people? That's right, an h. The first thing is going to be f of x plus h, and then you're going to subtract f of x. Now, when I taught you the difference quotient, I highly recommended doing this in 2 steps. The first thing we're going to calculate is f of x plus h, and I want all the work neatly organized there. And then on this side, I will do the difference quotient. So first, plugging in a quantity, I have to square my input plus 5 times my input. So first I have to take my input and square it plus 5 times my input. Let's go ahead and take the quantity there and square it. So that's going to be x squared plus outers and inners, good, 2xh plus h squared. Then let's distribute the 5. There we go. Okay, now it's time for difference quotient. So I really want to make sure that you're labeling your 2 kinds of calculations. At this point, you're going to be writing a fraction with an h in the bottom. Okay, the first thing you put is this huge f of x that you already calculated, the f of x plus h. So I write down all those terms, and then I have to subtract f of x. So I have to take these f of x terms, just the regular ones, and subtract them. So first I'll subtract x squared, and then I will subtract 5x. If you're doing things right, lots and lots of things should cancel. Okay, please don't do too much at once. The next thing I'm going to do is write what I have left. 2xh plus h squared plus 5h all over h. Then I'm going to factor out the h. Taking the h out, that leaves me with 2x plus h plus 5 all over h. And the last thing that happens is the h's cancel. Just for the sake of space, I'm going to go ahead and box up that final answer. I probably should write it again, but you wouldn't see it. It's off the paper. All right, let's review our domain rules. Remember, there are 3 rules. The first rule is for radicals. Radicals do not like negatives. So that means your expression has to be positive, or it could be 0, so greater than or equal to 0. If you're in the denominator, what do denominators not like? They do not like to equal 0. Now, if you're a radical in the denominator, if you're both of these cases together, then you have to think of both of them. Don't equal a 0, don't be a negative. So if you're in the denominator, it's just greater than 0. Let's work through a couple of examples here. The first example has a numerator, but that's not one of our rules. I'm only going to look at this denominator here. X squared minus 9. Denominators say, hey, don't equal 0. X cannot equal plus or minus 3. But we're going to make sure we spice this up a little bit. Okay, to state the domain says, hey, what am I allowed to put in? And I don't just want to tell people what not to put in. I want to tell them what they can put in. They can put in all real numbers, except plus or minus 3. Very important. You add that on and state it the right way. Okay? All right, I have an expression in a radical. So that expression, here's the rule, has to be greater than or equal to 0. I will subtract the 7 over and divide by 6. And in this case, you're not going to say all reals except, because there's a lot of numbers you're allowed to use. And I'm just going to tell all the people the ones they can use. Use all the numbers greater than or equal to negative 7, 6. Okay, it's going to get a lot more interesting here. Letter C, I see a quadratic in a radical. So first, I state the expression. And since it's under a radical, you're going to say greater than or equal to 0. Now, which one should I move over and square root? Neither of them. You do not square root with inequalities. There's 3 steps. The first step is we're going to factor greater than or equal. Don't forget the rest of the equation here. Since the number's first, I'll put tens first, plus x minus x. Step 2, we draw a number line with the plus minus tens. If this is an equal sign, you close up the bubbles, and now you test the sections to see where it works. If we take the number 0, you can plug it into this line. I think this one might be easier though. 100 minus 0. That's more than 0, so that's a good set of answers. Is things like 11 going to work? Or 20? Let's see. 100 minus 121. Nope, that's not going to work. And neither is negative 11. So don't forget to officially write down the answer. Negative 10 is less than or equal to x is less than or equal to 10. Remember what we said to use for these? Less than signs, small to big, looks just like your picture. The picture will help you get it right. And I need to see this work. This testing right here is how you figure out where the answer is. Okay, letter D has a denominator. Absolute value of 3x plus 5 minus 7 cannot equal a 0. Let's see, we'll add 7. But I still have these absolute value signs in the way. How do you get rid of absolute value signs? You make 2 equations. So I'm going to take the 3x plus 5, take the things inside the bars, and I'm going to make 2 problems with it. I'm going to say not equal to 7, and then you change this to negative 7. So let's solve these 2 equations. First, we subtract 5 and divide by 3. Then we subtract 5 and divide by 3. Okay, so what numbers am I allowed to use? Well, it's all real numbers in the world that you want, except do not use the number 2/3 and do not use the number negative 4. Those will not work. And you can check to see if they're going to work. Take the number negative 4. Really? There's a problem with that? Let's go see what the problem is. 3 times negative 4 is negative 12. Negative 12 plus 5 is negative 7. But The absolute value of negative 7 is positive 7. 7 minus 7, uh-oh, makes bad news in the bottom. Okay, I agree. Don't plug in a negative 4. Last domain review. The last one here, I see a radical and I see a denominator. So we're going to have to consider two things. The expression upstairs has to be greater than or equal to 0, but the expression in the bottom cannot equal 0. So my first equation here, this inequality is saying be more than or equal to a 7. Okay, I will. Can I square root with a not equal sign? Yes, this answer is going to be not equals. X cannot equal plus or minus 8. And I don't want to be redundant, and I want to make sure I say everything. I think a picture would be a great thing to do here. So here's the number 7, and he says be equal to a 7 and go greater, greater, greater. But he does not want you to equal an 8. So 8 is going to be an open bubble. Greater, greater, greater. In fact, he does not want you to use negative 8 either. Okay, but don't worry. I don't plan on using negative 8. I only plan on using 7 and more. So I don't think I need to say, hey, and don't use negative 8. Because when I tell everyone use 7 up, use some 7 up, then you're not going to be using that number. So the answer is x is greater than or equal to 7. Oh, but don't use 8. That's the perfect answer. So you don't want to say the negative one. Okay, what else did we study that you should probably know? Let's review factoring a little bit here. Okay, factoring review. The first thing I notice is I have a quartic, x to the 4th. So that separates into x squared, x squared. Okay, 36. The way that a 36 can break up and make a 13 is not 6 and 6, because that makes 12. How about a 9 and a 4? But if they're both negative, that'll make a positive. Let's check. Outers and inners. Yep, that makes negative 13. Okay, but that is not completely factored. This is a difference of squares, as is that. So the final answer is x plus 3 times x minus 3. Let's write some more. I can either bring that down or factor him further. X plus 2, x minus 2. When this is a 4th power, you should have 4 x's. Number 6, I'm going to factor by grouping. So let's look at this first 2 and take out x squared. That leaves us with x minus 2. Looking at the next group, I'm going to take out a plus 5. You must write plus or minus 5. If you stop at this point, distribute, distribute, plus, distribute, distribute, it should make 4 terms. If you have nothing but a bunch of parentheses, that means times, 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 it's not equal. Since I have duplicates, I can say x squared plus 5 times x minus 2. Can this one get factored more? No, because it's a plus sign. And number 7. There's a variety of ways of doing this. We could make an MA table. Maybe I'll show you that technique. Just to review, 4 times negative 12 is negative 48, but has to add to 13. So I don't think 1 times 48 will do it. 2 and 24? Nope, too far away. 3 and 16. We might be onto something here. A 3 and a 16 can add or subtract to 13. How many of them are going to be negative? Just one of them, the 3. Now you split the middles. 4x squared minus 3. Since these are x's, it would be x. If you were to split the middles here, x squareds would have to split into x squareds. Single x's split up into single x's. And you could check to see, do those two add up to 13x? Yes. Then we'll do factor by grouping. Take out an x. 4x minus 3. Take out a positive 4. 4x minus 3. Final answer is x plus 4 times 4x minus 3. Now we're not going to say equals to 0. We cannot solve this. This is not an equation. It's just a factoring expression. Okay, a couple other things we studied that you should be ready for the quiz tomorrow is on operations. So f minus g of x. So this says take the f of x and subtract the g of x. Okay, the f of x minus the g of x. X minus 6 over x plus 7. And then I have to subtract the g fraction. All right, how do you subtract fractions? You have to make common denominators. I'm going to put all of these expressions here, all these quantities in parentheses. This second fraction needs to get an x plus 7 quantity. And remember, what you do at the bottom, you must do to the top. I need to see that 2 times. This fraction over here is going to get x minus 3. Now I'm going to leave the denominator in factored form. That helps when it comes time to do things like domain. The numerator I am going to go ahead and multiply out. So let's go ahead and do firsts. X squared. Outers and inners is going to be minus 9x plus 18. Now I highly recommend using parentheses around that first quadratic. Then we'll put the minus sign, and then I will put another set of parentheses for the quadratic that I make here. And then the minus sign, I will subtract them once I make them. 2x squared is for the firsts. Outers and inners. What's 14x plus 7 more? Was it 21x? And lasts is plus 49. Okay, kind of tiny there. Let's distribute the negative. X squared minus 2x squared is negative x squared. A negative 9 and a negative 21x is negative 30x. 18 minus 49. 18 minus 49 is going to be negative 31. And this is all over x minus 3 times x plus 7. Oh my goodness. Wow. Okay. Now that we made the f minus g expression, they want us to use it. F minus g of a 2. First of all, am I allowed to put a 2 in? I think so. I think so. So f minus g of a 2. That's going to be negative 2 times 2 is 4. Minus 30 times 2 is 60. Minus 31. All over 2 minus 3, negative 1. 2 plus 7 is 9. So the denominator is negative 9. And the numerator is negative 95, which will become a positive 95 over 9, which I don't think can cancel, because 9 can't cancel by 5, and 95 can't cancel by a 3. Okay, next one. Let's do f divided by g of an x. Oh my goodness, I see an f, and I see a g, and I see a fraction. I certainly don't want to make a quadruple decker. So instead of a divide sign, I'm going to use the old school one. So let's do 2x plus 5 over 2. And let's divide it by g, which is 3x over 17. So let's go ahead and flip the second one. 2x plus 5 over 2 times 17 over 3x. So the denominator is going to be 6x. I'm going to write that number out in front of the radical. That way it doesn't accidentally look like it's underneath the radical sign. And there's f divided by g of variable x. The last thing we're going to review here is how to determine a function. The vertical line test is the way to go, real easy to show as long as you draw some vertical lines on your paper. If it doesn't touch, that doesn't count. If the vertical line ever touches two places, it is not a function. You draw a bunch of vertical lines, and then you say yes or no. Is this a function? Vertical lines are only touching one time, even though they're not touching here on this asymptote. Every other line is touching just once, and so the answer would be yes. Okay, the next thing we're going to go over here is how we're going to start writing everything in pre-calculus. So this will not be on the quiz, but we have to learn how to do this. So I know in grade school you guys did number lines and you used inequalities, but now we're doing interval notation. Interval notation uses parentheses for open. Okay, so if it was an open bubble to an open bubble, it would be like that. Brackets are for closed, so a closed bubble to a closed bubble. And you always use parentheses on your infinities because it goes forever and you can't get there. So you look at this number line. It starts at -10 with a closed bubble. Since that's included, we do brackets. -10, comma, all the way, all the way, all the way. And since it's an arrow, it goes forever, you say positive infinity. And you put a parenthesis on the infinity. So interval notation is how you say the number lines, but not with greater than less than signs. Okay, this one here has two pieces. They look just like the number line. So start in the small end. This is pointing all the way at negative infinity. What do we use on infinities? Parentheses, comma. And you keep going, keep going, keep going until the number, was this -6? Now, -6 bubble is open. So we're going to use parentheses. That means not included. That means all these decimals are used, but not the number -6. And now there's some more. So you draw a U for union. Okay, this means union, and that means and there's another piece. So starting there at +6, I'm going to put a bracket, +6, all the way to infinity. Okay, we are going to practice this the next couple of days. I just wanted you to see it so that we can start writing with it and you know what I'm talking about. I see two pieces here, so start on the left. Even though it's going left, we start with that. We say -infinity with a parentheses all the way up to the number 1, 2, 3. Since 3 is closed, you put a bracket. And how do we say and there's another piece? Union, starting at brackets 5, since it's closed, all the way up to infinity. Let's do another one. I see two pieces here. -infinity, all the way up to the number, is it -1? Parentheses or brackets? Since it's closed, you'll use a bracket. And some more, so say union. What number is that? 0, 1, 2. Does 2 get a parenthesis or a bracket? Parentheses for open, and it goes as high as positive infinity. What do you always put on the infinities? Parentheses. You can't get there. It's more of an idea. You can't get to infinity. Okay, last one. Oh, this is kind of weird. It starts at -infinity and goes all the way up to 0. But it doesn't use 0. 0 is open bubble. So how do you say don't include 0? Parentheses. But now there's some more. So we're going to say union. Where are we going to start? We started at 5. Some people say let's start at 5 with a bracket. But then I say what about all these numbers here? So you're going to start right where you left off. Start right at 0. And you're going to go all the way to infinity. So the question is, how do I state a whole? A whole is when you use the number, don't include it, start again at that same number with parentheses, and that is how you state a whole. Good luck studying for tomorrow's quiz.